Okay, continuing superposition. What we have here is a circuit with two sources, a voltage source and the current source. Realize the flow of current and the source polarity here in terms of the voltage source. There is a 2K ohm resistor and a 1K ohm resistor in series across the 2 milliamp source. And of course there's a 6K ohm resistor across, which is V0 is across that 6K ohm, right? So we are required to find V0, and we're going to use the principle of superposition to find V0. What's the problem solving strategy for this using superposition here? Right? And obviously this could be a FE style problem, right? This could be a FE style problem. So principle is identify independent sources in the circuit. Where are independent sources? Those two. Lay out all circuits such that each circuit has only one source turned on and the remaining turned off. So we're going to have to turn on one source and turn off the other source. One source on, the other one's off. Then to turn off a voltage source, you replace it with a short circuit, right? So remember, the voltage source, to turn it off, you replace it with a short circuit, right? And you replace that with a short circuit. To turn off a current source, you replace it with an open circuit. So you replace the current source with an open circuit. Right? You replace that with an open circuit. Now you solve each circuit individually with all circuit laws or techniques in consideration. And the results of applying each source independently, then you add them algebraically together once you to obtain the final solution, right? So in a circuit like this, let's for instance these two sources, that particular circuit, let's use one source at a time. At this instance, let's first turn off the voltage source. Let's turn off the voltage source. If we turn off the voltage source, what we have is, we have a 2K ohm resistor and a 1K ohm resistor here. Then we have a current source. Remember, replace this with a short circuit. So we're going to have a short circuit here. Then we're going to have the 6K ohm resistor across that. And this is V0. So now what we have is a 2 milliamp source, essentially a 2K ohm and a 1K ohm resistor. And we short circuit out the 3 volt source. Now, we'll try to solve this problem using superposition, right? So with this 2 milliamp source, the circuit can be simplified as follows. Look at R. To find R is what? Resistance total is what? You have what? You have 2 resistance in series and 1 6K in parallel, don't you? Right? That's where you have to get the total resistance, right? So how do we work that out? So if you're 2 and 1 is 3K, so 2K plus 1K is 3K here. 2K ohms plus 1K ohm equal 3K ohms. And this branch, right? And then RT now is equal to product over sum of these in parallel. These two in series with that one, the 6K in parallel. So product over sum is 3K ohms times 6K ohms over 9K. Over 9K, right? So that should give you the resistance total, and that works out to be 18 times divided by 9 is 2K ohms. So that is the resistance total of 2K ohms. And as we said before, we're using superposition here, which means we turn off the voltage source, short circuit, which would have been here. So you only have the current source in the circuit, right? So that comes out to be resistance total of 2K ohms, right? Now, you say you get that that 2K ohm for resistance, R sub T. Let's say it's R for now. Now, now to find V sub naught prime. So V sub naught prime. How do we work that out? It's actually what? What's the current? 2 milliamps, right? 2 milliamps multiplied by 2K ohms, right? It is going to be, the voltage is going to be 2 milliamps times 2K ohm, which was the resistance. That will work out for the total in this configuration, and that comes out to be 4 volts. So that 4 volts is the first voltage when the voltage source is off and we're only using the current source, right? Now, let's do it, replace now, let's do the configuration with the voltage source only and get rid of the current source. How do we get rid of the current source? The current source replaced with an open circuit. If the current source is replaced with an open circuit, it's going to be a 2K ohm resistor, a 1K ohm resistor. This is open circuited, so it doesn't count, right? Open circuited, and then you have minus and plus. V sub naught prime, this is V naught here, V sub naught plus and minus, and then this is 6K ohm resistor. Right, so what you have essentially here is this time we have basically a circuit with V sub naught across V sub naught, the 6K ohm resistor, and again these two resistors in series. So how do we solve this circuit? You could break it down if you realize what's going on here. I mean, we could get the current flow in the circuit, and then we could use that current flow to determine the voltage V naught, can't we? So let's try that. Let's find out the current around this entire loop, right? How do we do that? V equal IR, right? So I is equal to V over R, correct? What is V? In this case, this is a 3 volt source. So this is 3 volts divided by the sum of the resistance, which is 6K plus 2K plus 1K. That works out to be 3 over 9K, which is 1/3 milliamps. Correct? What does that 1/3 milliamps means? That 1/3 milliamp means that there's a 1/3 milliamps flowing around in this circuit. Now, how do we find the voltage across V naught? Well, this 1/3 milliamp will be here, won't it? Right? So the voltage across V naught, which is V naught double prime, which is the second piece when the current source is off and the voltage source is on is going to be I, which is 1/3 milliamps, or 1/3 times 10 to the minus 3 times R, which is 6K ohms. That's going to be equal to what? Well, 6K ohm is also 6 times 10 to the third, isn't it? 6K ohm is 6 times 10 to the third, which is equal to 2. 10 to the minus 3 cancel 10 to the third. So that's going to be 2 volts. Well, as superposition principle states, in order to find V naught, V sub naught is going to be the sum of V sub naught prime plus V sub naught double prime. Now that is going to be what? V sub naught prime is 4 volts plus V sub naught double prime is 2 volts. That works out to be 6 volts. So 6 volts here is a voltage across this point, which is this point. So here they're going to be 6 volts. It's going to be here across it. Right? So the answer here is B. And this could be solved other ways, by the way. For instance, you could use nodal analysis to solve this problem, right? You could use nodal loop analysis to solve this problem too. So you could solve this problem variety of different ways, but today we are set out to solve it using superposition.